All right, let's look at Theorem 2, Triangle Inequality in vector form. All right, so it says that vector u dot vector v is less than or equal to the normal vector u times normal vector v. Right? It is kind of hard to see that this is triangle inequality. So let's look at a picture. All right, so let's say you have a triangle, right? And the triangle inequality said that, say this is vector u, this is vector v. So this is just a sum of those two vectors, right? So length there is a norm of u plus norm of vector v is going to be greater than or equal to the norm of vector u plus vector v, right? So regular triangle inequality give us norm of vector u plus norm of vector v is greater than or equal to norm of vector u plus vector v, right? Then we can, since these are all positive quantities, we can square both sides. So we get this, square both sides. So we have a norm of u plus norm of v squared is still greater than or equal to the norm of u plus v squared, right? Then if you multiply all out, you're going to get the norm of u squared plus 2 norm of u times norm of v plus norm of v squared. Right? This is greater than or equal to. Alright, so this is norm square. It's just a dot product with itself. So vector u plus vector v dotted with itself. So it's going to be u times u is norm of u squared, and you have a u plus u dot v, and then you have a v dot u. Then you have v dot v, which is the norm of v squared. Then you can see that we can cancel norm of u squared, and those are both sides. Norm of vector v squared is on both sides. And this guy right here, since dot product is commutative, it's same thing as u 2 times u dot v. So then you can cancel 2 here and 2 there. Then you end up getting the norm of u, times norm of v is always larger than or equal to u dot v, right? That's how they got this triangle inequality, right? So this is why it is called triangle inequality. But if you the slickest way to prove it would be using a law of cosine. So remember, we have a law of cosines in vector form says that u dot v is equal to norm of u times norm of v times cosine theta. But remember that the cosine theta is always less than or equal to 1, so this guy is less than or equal to norm of u and norm of v. Alright, since cosine of theta is less than or equal to 1. So you're replacing this guy by 1. Right? Then that's the inequality we wanted. So this is probably the slicker way of proving triangle inequality. But the first one is more meaningful because you actually start with the triangle inequality. Alright, that's theorem 2, triangle inequality in vector form. Alright, that's it. I hope that this was clear.